So now you can see. So the question was, is this 9 or is it 1?
9.
Okay.
If you think it's 1, you don't have the order of operation.
It's 10 dollars. It's 10 dollars.
Parentheses first, exponent plus exponent.
Okay, so the question is, thank you for the conversation, but listen up now. The question is, what do we do next?
Here.
Let me explain. This is what you probably have heard, you've probably seen it on the board for every classroom since you first learned it. However, there's a flaw with this. We follow this exactly. We did the parentheses, okay. There are no exponents, okay. Then we multiply, so we'll do 6, and then 2 times 3, and then you get an answer of 1. If you follow this, multiply, then divide.
That's wrong.
As some people have already figured out that it's really not multiply and then divide. This is flawed. It should really be multiply, divide, divide, multiply, from left to right as they appear. So you don't want to do the multiplying first because the dividing actually shows up. So we have 6 divided by 2, which is 3, and then multiply times 3, and your answer is 9. So I point this out because it is commonly missed. As you saw, we had about half and half. So as we're going through these problems, these are specifically picked to test your knowledge or to figure out what you already know. You might be a little rusty at some of the stuff. I'm not saying this is what you do right now is probably your best work, but I wanted to remind you about these little things. If we rely on these kind of acronyms and that's all we go off of, it can get you in trouble. Things like P flip flip and all this other stuff, yeah, they might have worked at some point. They work an awful lot most of the time, but if you use it for everything all the time, it can get you in trouble. So I prefer to use something called GEMDAS, just because, well, we have other grouping symbols other than parentheses. So we have parentheses, we have brackets, and we also have braces. So those are all grouping. Then multiply, divide, add, subtract from left to right as they appear. You cannot just say, well, multiply everything, then divide everything. It'll mess you up every time. Unless we got this stuff down cold, algebra is going to be very difficult because it's like you're trying to learn 2 classes at once. You're trying to do pre-algebra and algebra all together, and you're like, how come this is crazy and I don't get it? It's because you're trying to focus on too many things. We want to get to the point where you don't have to think about this. It's 100% correct always. Same thing every time a fraction shows up on a problem. You're not going to stop and say, oh, this is harder because it's a fraction. You don't want to ever say that. You don't want to say this problem is harder because it contains a number from the 4th grade. Right? Doesn't sound very good when you say it like that. Say, I might be a little rusty at this fraction stuff, but I can do it. We're going to keep practicing so everybody can take a 30-question fraction quiz any time of day, and you'll ace it. Okay. That's what we're going for. All right. So, little details. What's the difference between an expression and an equation? An expression is what we just did. Okay. Something like that. That's an expression. How do I make an equation out of that? You know, I'll add a variable and I'll throw in an equal sign. That's an equation. So the front side is expressions, the back side are equations. Okay. Solving for something you don't know, unknown, as opposed to just simplifying. Yeah.
How would you even get one of that one in?
What?
The question we did when it was,
Yeah.
Is it 9 or 1? How would you even get one?
Oh, if you did the multiplying first, you do 2 times 3 against 6, 6 divided by 6. That's the other one. Do the question. Okay. let's actually just go to the worksheet. Ready? Okay, so let's get started. And again, you can watch this again later if needed. If you're absent, your go-to is always to go to the internet first. If you don't have internet at home, and you can always check in here in the morning, go to the library, things like that. But it is expected that you do that. You never show up saying, I wasn't here for 3 days, what do we do? Same thing with your classes for your teachers at your school. That's why we spend all the time. Alright, so again, you guys heard I'm not a big fan of learning all these cute rhymes, and they work sometimes, but then we use them in the wrong places and get things wrong anyway because we don't really know what we're doing. So when it comes to positive, negatives, adding, subtracting, it's really just counting. Hot and cold, right? Hot and cold. Negatives are cold, positives hot. Temperature goes up, temperature goes down. So if you're at -3 degrees and you go down 5 degrees, what's the temperature? -8.
You know, multiply?
Right? It's a subtraction. Right? So if you can also think about this as money. You spend $3, spending money, getting money. Spending $3, spending $5. How much money have you spent? $8. Negative since you spent it. You're down $8. That's all. You don't need fancy rhymes and stuff to get you through. Okay, we're going to practice it right now. That's what we're doing. So you know you can spend $3, and you can spend $5, and altogether you spend $8. That's all we're doing. We'll do a little bit more as we go along. Next one. Go down. What happens if you have two negatives next to each other? Positive.
Okay.
Why?
Because double negative.
What? Negative. But why does that happen?
That's the way they made it.
See, and that's the catch. You're usually not taught this and why. So we need to know why. Not just because then it just turns into some rules. Turns into some rules you've just memorized. And you don't really know why you're doing something, which leads to some trouble.
Because negative can also mean the opposite of something. So if you have a negative with a negative, it can be the opposite of a negative.
It's a really good way of looking at it. Another way of looking at it, without any math reference at all, you already think this way. You already think this way. So if you think of something like a negative number, just think of anything that's negative in general, bad, negative, and you take that away. So what happens if you take away something negative? You get rid of something that's negative. Get rid of something that's bad. That's a good thing. Get rid of anything that's bad that you've ever done, not in math class, but in life. Anytime I've gotten rid of something bad, that's a good thing. That's exactly what this means. It's just in symbols instead of words. So, more logical, we're counting money. The temperature goes up, the temperature goes down. If we take away something bad, that's good. The numbers behave the exact way you already think. What gets in the way that makes math difficult is trying to remember all these rules and we don't know why you're doing it. And it just seems like, well, this is different from everything else. Math doesn't really do anything in life. It's just something completely different. Really, it's the same thing if we look for it. All right, and of course, go ahead and finish it up. I personally look at this and I think 7 and 8 is 15, and then plus 5 is 20. For me, the multiples of 5 are easier to think about. But of course, 7 plus 5 is 12, and plus 8 is 20 as well. So like at this point, just saying equals 20 is perfectly fine. You don't have to do one step for two numbers and another step. But definitely you should have 2 steps for this problem. So here's the point where you say to yourself, wait a minute, the teacher just said I have to write this down. Don't say to yourself, well, I don't need to do that because I thought I don't need to do that. You're going to show me all the work so I know what's going on in your head, and you can show me improve it. So if right now you have just numbers, one number for each problem, you're going to go back and you're going to show every step so you're proving what you know. Not just saying I know it and say because I know it. Imagine somebody designing a car and saying, no, here it is. No, I know how to make it. Okay, why don't you show us? No, I just know how to do it. I can do it in my head. You can't do that. That's real life. You can't just say, well, I know it. Well, how do you do it? Well, I didn't write it down. So you can't show anybody that what you know how to do? No. Go find another job. Okay? You have to be able to show and tell, explain to other people your reasoning for an answer, not just say, I do it in my head. But I guarantee after about 2 months in Algebra 1, none of these problems you'll be doing in your head. If you're not used to showing work and proving yourself on easy problems, it doesn't turn on all of a sudden when you get the difficult problems. Okay. So day 1, tomorrow, if you show up with just answers or just kind of some of the work, you get that C-. That's where you're at until you start proving to other people, proving to me that you know how to do it. It doesn't count. Not because that's my rule, but that's just the world. When we were going to use this in real life you have to show and explain to other people, not just say, I got it. Okay, let's skip down a little bit. How about number 9? Good to have a plan. It's already getting a little more difficult, right? Before we even start with the numbers, go in and think to yourself, I need to get this answer first. Whatever the bottom denominator is, I need to figure out what that is. Then I'm going to divide that into 10. Then I'm going to subtract 3. That's the steps. I'm going to have to figure out what this is, divide it into 10, subtract 3. I'm not going to get confused or lost along the way. Have a plan to start off with. So here we go. Since I'm going to be doing the 10 and the minus 3 last, I'm just going to rewrite it until I figure out this denominator. So I'll just copy it down, and let's just do the bottom. Minus 1, do parentheses. Actually,
So it's basically a fraction, and then you turn into a...
yeah. So yeah, 6 minus 2 is 4. When you only have one number in the parentheses, that's when you can drop the parentheses. The parentheses are for grouping, which means you have lots of numbers. But if there's only one number inside parentheses, you don't need it anymore. Okay? 10 over. What's let's see. Spend $1, spend $4 more. -1 minus 4.
-5.
-5. Spend $5. Don't forget to bring down -3. Remember, these have to be equal to each other. You can't have a -3 here and not here, because now it's not the same thing. And then keep going. Division and subtraction. Do division first. 10 divided by -5. -2. Bring down the -3. Spend $2, spend $3. You spent 5 altogether. So again, for this is the kind of work I expect. And I'll tell you, I'm actually one of the more lenient teachers on showing work. There's other teachers that will have you show even more. They'll only let you do one little thing per step, and the problems are even longer. So don't think for a second that somehow this is the harder class because you have to show you work anywhere you go. So if you accept that and just kind of go with it, you'll be okay. Yeah.
So what if it's not a fraction, and we have a number, but it's subtracted by another number of parentheses?
Give me an example.
Like number 7.
So 2 minus 1, 1.
Would it be in parentheses then?
Well, you can drop the parentheses because there's only one number left. So after you do 6 minus 5, there's only one number in the parentheses, so you don't need the parentheses anymore.
So with the 4, we can do the same.
The 4? Which one?
Yeah.
Yeah. Yeah, I dropped the parentheses in. Yeah. 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 Good questions? Negative. So it's 6 minus 2 is 4. And then there's a minus out front. Because if you spend $1, you spend $4. Altogether, you spend $5. -1 minus 4. Yeah, think of this as two numbers. Think of this as that's a -1, that's a -4. -1 and -4 is -5. Any questions? You guys will be helping each other a lot when you're doing this. Where the backside is. Try this again. There we go. Let's take a look at the back. Alright. More, again, my ethos today is understanding what you're doing, not just trying to bring up those steps that you memorize and just follow them, and then hopefully that gives you the right answer. Even though it does most of the time, let's figure out what we're doing.
On basic, on like number 14, you have to show work.
Show work on everything, please. That's the name of the game. Once we get going into the middle of the year, and you've proven to me you can do some basic stuff, things change. But for now, I don't know you. I need to know what you know. So something like this, number 13. Before you go into the autopilot, subtract this to both sides, add this to both sides. Think about something more common sense. Like this. What minus 15 equals 1?
14. 16.
16 minus 15 is 1. That's it. Now go through the steps of proof. So it's not about, hopefully at the end you get a number that works or something like that, but some of these, when they're basic like this, okay, we can just figure out the answer from the beginning because, well, it's not that difficult. I know 16 minus 15 is 1. If we remember the algebra correct, we want to go to the side of the variable, do the opposite operation, opposite subtraction and addition. This only is true when you're adding, subtracting, you do the opposite. Because that equals 0. We're trying to get 1x or x by itself. That's the way to get it. Equal signs should line up. You know, the left and the right hand side should be very clear. And of course, you can always do a check. Plug it back in. See if it works. If you get the same thing on both sides, it's 100% correct. Every equation on every test you can check. Some are more difficult than others, but if you're really concerned about your grade, you always do that second part to make sure it's actually correct. Don't turn in a first draft. Don't turn in, well, this is what I got the first time. Hopefully it's right. Please grade it, and hopefully it's okay. Check it. You should turn in your grade on equations, turn in your test on equations. You already know it's right or wrong. Hopefully right. Not a, you know, we'll see what the teacher tells me. But you already know before you turn it in.
And you have to check it.
Please do a check. We'll throw in some double negatives once again. After you get to this point, taking away something negative, that's a good thing. That's positive. Not a math rule, it's just that's a standard rule for everything. Anytime you take away something negative, that's a good thing. What number plus 5 is 8? 3. You already have an idea of what the answer should be before you even go through it. Okay? And if you don't get 3, you stop and say, what happened? I thought I was going to get 3. So if you accidentally add 5 right here instead of subtracting 5, you'll catch yourself. Do the opposite. Opposite of addition, subtraction. 3 is what the unknown number equals. The number equals 3. N equals 3. course, 8 equals 3 minus a negative 5. Eight equals 8. Answer is correct. The numbers match. Numbers match, you're correct. A few more. Remind you about the fractions and then multiplying and dividing. Our goal is to get m equals, right? What do I need to do to get from negative 18 to m? Divide by negative 18. Why negative? Because we're trying to get positive 1. When we say x equals, y equals, a equals, b equals, we don't really say the coefficient in front of that, which is a 1. We don't usually say 1m equals something or 1x equals something, but there is a 1 there. That's what our goal is. How do you get 1? How do you get from negative 18 to 1 by dividing? Divided by negative 18, that gives you 1. That's why we divide by the same sign. We're trying to get positive 1. It gets confusing because up here, what do we do? Oh, the signs are different. Why do we do that? We're trying to get 0. We already had 1x. We're just trying to get rid of this so it equals 0. The way to get 0 was to use opposite signs. The way to get 1 is you have to use the same sign. And then, of course, what's the sign of the answer? Is it positive or negative?
Negative.
Yeah. Write that down first. That's the number one mistake. Is a positive or negative. And then do the arithmetic. 270 divided by negative 18. You guys.
15.
15. If you go out and get your calculators, this is not something you have to hassle with during a test or in a quiz. You just punch it in there. Notice how it won't do the signs for you. If you forget divided by a negative, your answer is still wrong. It only takes care of the arithmetic. It won't do the algebra for you. So be very careful because the number one incorrect response would be 15. And that's 0%. You don't get anything. Yeah, you did most of it right, but missing a sign, you might find this when you're, as you've gone around, somebody owes you $15. Is that the same thing as you owing them $15?
No.
Yeah. If you get one negative, it means a completely different thing. We can't make excuses like, oh, I did everything right, I just forgot a negative. Wait a minute, now you're spending now you're giving money to somebody else when they should be giving money to you.
Yeah.
That's a big fail. Yeah, you just mess up a lot of things. You know, if an accountant, somebody that does all your taxes, forgets one negative and says, hey, you owe the IRS $10,000. Oh, wait a minute, I forgot a negative. They owe you $10,000. Oh, I guess a negative is important. We can't just say, well, I got everything right, but a negative, it's okay. It's mostly right. You want to get away from that. Yep.
So 15 isn't right?
Negative 15. Negative 15.
That's right.
That's right. 270 positive divided by negative is negative. Yep. Negative. Signs don't match. Yep. Same idea. Let's keep actually both of these on the screen. Our goal was to get 1m here. Our goal is to get n here, 1n. So 2 over 3. Come on. 2 over 3 times what equals 1? What can I multiply by 2 over 3 to get 1? 3 over 2. That's what we call the reciprocal. Why did you multiply the reciprocal? Because it gives you 1. Just like over here, negative 18 divided by negative 18 is 1. It's all about getting to 1. So 6 across, 6 on the bottom, 6 divided by 6 is 1. Multiply both sides by 3 over 2. I know a lot of you just memorize, when you have a fraction, you do the reciprocal, and who knows why you do that, you just kind of do it. We're trying to find out how much 1n equals. On the other side, here's a truth for algebra and pretty much any class. When you have a fraction answer, in this case it's going to be negative 15 on top, 3 times negative 5. On the bottom you're going to have 2 times, and there's no number here, which is the same as 1. 2 times 1, which is 2. If you want to, you don't have to. If you want to, you can put over 1. Not necessary, though. If this is fully reduced, you are done. You don't have to change this to 7.5 or make it a decimal like negative 7.5. Reduced fraction is perfectly fine. If it's a word problem, however, like if this is asking how much money do you owe at the end of week 2, you wouldn't say I owe negative 15 over 2. In that case, a decimal would probably be good. Negative 7.5. I owe $7.50. So, in the context of a word problem, use the correct format, use the correct units. When this is not a word problem, it's just practice, reduced fraction is perfectly fine. Okay. Different little things. Some people prefer this when you have a fraction with a variable. Remember, it's 1x, and if you prefer, you can move it over here and make it 1/3 x equals 21. Let's do some number sense, and then we'll be done. Number sense says you will have to multiply something by 1/3, or another way of saying that, you have to divide a number by 3. You have to break something up into 3 equal parts, and each of those equal parts is going to be 21 units big. Is your answer bigger or smaller than 21?
Bigger.
Bigger or smaller? What do you think?
Correct.
Yeah,
Big.
bigger. Yes. Now, I can tell that you're used to thinking about log problems, not just memorizing steps. Usually it's not that quite obvious. Yeah, if you have to break something up into 3 equal parts and each 21, the bigger piece has to be bigger than the parts, right? However, if you get into autopilot, well, you do this to both sides, or you see multiplication, you see a 21 and a 3, you think, oh, 7 times 3 is 21, the answer is 7. That doesn't make sense. Break 7 up into 3 equal parts to get 21. Doesn't make sense. So again, exercise some precautionary common logic here. These questions I'm asking you, like, is it going to be bigger or smaller? They're actually easier to answer in elementary school because you're not bogged down with all these steps in your head like, well, I have to do this on both sides, and that on both sides. Yes, a kid this, but they're like, bigger. They know, because they're breaking up into smaller pieces, so you have to start with something bigger. So try to tap into that. Don't overcomplicate things in your head where, you know, your first thing you go to is just a bunch of rules that may or may not be helpful. Okay? So yeah, multiply both sides by 3 over 1. X equals 63.